Converting forms of quadratic equations. Okay. So it says convert the following quadratic functions from factored form to standard form. So remember, standard form is just it written out like an ax squared plus bx plus c. It's just expanded out into that form, that standard form. So in order to convert these, we need to just distribute and expand this thing out. So let me rewrite that ax squared plus bx plus c, just so that we know that's the goal. I'm going to write that above the word standard form because that's what we're trying to achieve. So how we're going to do this first, and I guess there's different approaches you can do it, but what I like to do is just distribute that out first, expand that. And then after I expand that, I'll multiply the 2 to it. So I'm going to expand that out first and then multiply the 2 to it. So I'm going to expand this out. That's going to be an x squared plus 5x, subtract 3x, subtract 15. And again, I'm going to multiply this by 2. So I'm just going to rewrite that 2 right there. But before I do that, I'm going to combine my like terms in here. That's going to be x squared plus 2x minus 15. Okay. So I basically just distributed and did what was in the highlighted portion. So I expanded x minus 3 and then x plus 5. So I distributed, combined like terms, and that's what I got. And now I can multiply it by 2. I can distribute that 2. So it's going to be 2x squared plus 4x minus 30. That is the equation in standard form. Make sense? Hopefully. So this equaled this, and then I just multiplied it by the 2. So here, again, I'm going to do that part first, and then I'm going to multiply by the 3. So I'm going to have negative 3. So x times x is x squared. X times 6x is 6x. 2 times x is 2x. And 2 times 6 is 12. Let me combine like terms in there. That would be x squared plus 6x plus 2x is 8x plus 12. And then multiply the negative 3. In other words, distribute the negative 3. That'd be negative 3x squared minus 24x. And then negative 3 times 12 is negative 36. So minus 36. And let me just write the g of x here. There we go. Now it's in standard form. So that's like all it is. Just distribute those parentheses, those binomials in the parentheses, and then multiply it by that leading coefficient, and it'll be in standard form, just like that. Now this one's similar too. It says convert the following quadratic functions from vertex form into standard form. So we're still going to standard form, which is at ax squared plus bx plus c. And this process really isn't that much different because we're going to have to do some of that distributing again. So watch this. So write this. We're going to do this part first, x plus 5 squared. And remember, x plus 5 squared means x plus 5 times another x plus 5. I'm going to rewrite that plus 7. So yeah, I'm going to do the x plus 5 times x plus 5, distribute that, and then just get that, and then I'm going to add the 7 to it. So here we go. X times x is x squared. The x times the 5 when I distribute would be 5x. Let me draw my arrows. Okay, so that's 5x. This will make 5x. This will make 25. Still have that plus 7 out there. So combine some like terms. I'm going to have x squared. The 5x plus the 5x would give me 10x. And then I'm going to combine the 25 and the 7 too. Those are like terms. 25 plus 7 is 32. So there you have it. It's in standard form. Let me show you E. Same idea, but now we just have a coefficient of 2. So I'm going to write 2, and I'm going to do x minus 3 x minus 3 plus 10, because what I want to do first is this. And x minus 3 squared just means an x minus 3 times another x minus 3. So I'm going to do x minus 3 times x minus 3. Then I'm going to multiply it by that 2 coefficient, kind of like we did on number 1. And then I'll combine the like terms and add the 10 with it after that. So I'm going to rewrite 2. X minus 3 times x minus 3 would be x squared minus 3x minus another 3x plus 9. I just distributed that. And I still have that plus 10 out there. Now I'm going to multiply. So I'm doing this, which is now this after distributing. Now I'm going to multiply the 2 to all of that. So it'd be 2x squared. Well, actually, sorry. Let me combine those like terms first. So that'd be negative 6x plus 9. So I just combine the negative 3x and the other negative 3x to make negative 6x. Now I'll distribute the 2. So it's going to be 2x squared minus 12x plus 18 plus 10. And then I can just combine those. And I got 2x squared. Subtract 12x. 18 plus 10 is 28. Okay. So like, yeah, my work's pretty drawn out. You might be able to do it in maybe a step or few shorter. But yeah, like you didn't have to combine the negative 3x and the negative 3x to make negative 6x before distributing the 2. You technically could have distributed the 2 earlier. It doesn't really matter there. But the truth of the matter is you need to do that x minus 3 squared part first. You're going to get this out of it. And then multiply by the 2 and then just add that 10 to get it into standard form. Okay, hopefully those 2 examples were enough. Okay. Number 3 says, convert the following quadratic formulas functions from standard form to factored form. So remember, we're going to factored form. We want it in ax minus r1, x minus r2. So we're just basically factoring it. Now, it doesn't necessarily need to say minus on both of those parentheses, right? But that's the general form we're getting it into. So on A, first I'm going to factor out the greatest common factor of those terms. So I have a 3x squared plus 15x minus 42. All those numbers, all those coefficients or all those terms are divisible by 3. So I can factor a 3. So I'm going to have an x squared plus 5x, and then 42 divided by 3, that should be 14. So minus 14. So I factored a 3. And now I can factor what's in the parentheses. So I'm going to write 3. I'm going to have x. It's got a leading coefficient of 1, right? So what multiplies to negative 14 adds to positive 5. That would be positive 7 and negative 2. It's in factored form. Let me do G. So G, I have a negative 2 leading coefficient. So I got negative 2, negative 18, negative 36. So negative 2 I can factor from all of those. So I'm going to write negative 2. I'll have an x squared. Factor negative 2 from negative 18, that would be positive 9x. Factor negative 2 from negative 36, that would be positive 18. And then I can just factor that x squared plus 9x plus 18. So let me rewrite the negative 2. I'm going to factor that. X multiplies to 18, adds to 9. That would be 6 and 3. There you go. And it's in factored form. I'll let you try the rest of those. So you're just factoring. And remember, go back to a previous unit if you don't remember factoring and repractice some of that if you need to. Okay. Number 4 is a doozy. Now there's different ways to do this one. I'm going to show you the very mathematical way. It's going to be a challenge. It's definitely going to be a little more confusing and difficult than the other methods, in my opinion. But just hang with me. And the method I'm going to do this, and this is the very mathematical way, is using the completing the square method. So we're trying to write this in vertex form, which is ax minus h squared plus k. Remember, we're trying to write this in vertex form. Convert the following quadratic functions from standard form to vertex form. Okay. So we need that x minus h squared part. Like that's the tough part. So we're going to do that by completing the square so that we can get this this squared part. So here we go on A. Let's complete the square. So if you remember how we complete the square, and I'm not going to write it because I don't want to muddy up my work too much, but and you don't underline what I'm underlining. This 8, remember what we do with that when we complete the square? We divide it by 2 or take half of it and then square it. And then when we're solving equations, we added it to both sides, but I'm going to do something a little bit different here. Okay. So why isn't that erasing? What the heck? Okay. So what we're going to do is we're going to, again, take half of 8, which is 4, and 4 squared is 16. So I'm going to add 16 next to it. So I'm just bringing in a 16. I'm going to rewrite that minus 5. Now, typically when we completed the square, if I added 16 on the right side, I'd have to add 16 on the left side. But since we're trying to rewrite this as an equation of y equals, or in this case, f of x equals, I don't want to put anything on the left side. So to maintain the equality, if I'm just adding a 16 on the right side to counteract that, I'm also going to subtract a 16. Okay, because I got to keep it balanced. So if I just add a 16, I need to subtract a 16 to maintain equality. Now you might be like, what the heck are you doing? Why do I have a plus 16? Why did I do this? Well, the reason I did this is because x squared plus 8x plus 16 is a perfect square trinomial that factors into x plus 4, or in other words, this factors into x plus 4 squared. So this, what I'm about to highlight here, factors into x plus 4 squared. That's why I did it. That's why I did the plus 16. Because this factors into an x plus 4 squared that looks very much like that x minus h squared that's in the top right of the screen, trying to get in a factor form. And then all I need to do now is I'm going to combine the negative 5 and the negative 16. Negative 5 combined with negative 16 is negative 21. There we go. This is in factored form. I kind of want to erase that highlighting. There we go. Whew. Okay, so I don't know, maybe you followed it. Hopefully you did. I'm going to show a little more examples of this ones than the other problems above, just because I think it's kind of challenging. Okay, so here we go. We're going to complete the square on B. So x squared minus 6x. So I take half of negative 6, which is negative 3, and then square it. So negative 3 squared is 9. So I'm going to add 9 to complete the square. I'm going to add 9. And then I'm going to rewrite my plus 11 because that's still hanging out. But I just added a 9 there. So to counteract that, I could add a 9 to the other side of the equation, but I would just have to move it back over. So by subtracting it. So it makes more sense if I just add a 9 there. I'm going to subtract a 9 to maintain that equality. And now this x squared minus 6x plus 9 factors into x minus 3, or in other words, x minus 3 squared. And 11 minus 9 is 2. So there we go. It is in vertex form. All right, so you can try C and D. I'm going to show you E and F, which actually add a little layer of difficulty on it, a little extra step. So this might get a little crazy. Okay. So we only were able to complete the square when that leading coefficient is 1. Okay, so like notice on A and B, it was just a 1x squared, a 1x squared on A and B. This doesn't quite have that. So I'm going to factor a little bit first. Out of these first two terms, I'm going to factor a 2 from them. So it would be an x squared plus 6x. Okay? I'm going to rewrite everything else. So I factored a 2 from those two first terms. Now I'm going to try to complete the square with the x squared plus 6x in there. Okay, I'm going to try to complete the square with that stuff in there. So half of 6 is 3, and 3 squared is 9. So I'm going to add 9. Hopefully you're still with me. So I'm completing the square in there. Now I still have a plus 5. Now here's the thing. Again, poof. I magically just, to complete the square, I added a 9 to that side of the equation. But I need to counteract it. So you might think, oh, just subtract 9. But here's the catch. And this is where it gets really confusing. I didn't technically add a value of 9. That 9 is really, since this whole parenthesis is being multiplied by this 2, that 9 is really 18. Because the 2 times the 9 is technically 18. That's really a value of 18 because everything in that parenthesis is being multiplied by 2. So that 9 is technically an 18. So it's not just a 9 I need to subtract. I actually need to subtract 18 to maintain the equality. And if I lost you there, I am sorry. This is quite difficult. But now we can finish this problem up because the x plus 6x plus 9 factors into x plus 3 squared. And then 5 minus 18 is negative 13. So this is in factored form. Or sorry, not factored form, vertex form. Okay. F. Again, we need a leading coefficient of 1. This has a leading coefficient of 3. So I'm going to factor a 3 from that. So it'd be 3 parentheses x squared plus 4x. Now, I want to complete the square within the parenthesis. So half of 4 is 2, and 2 squared is 4. So to complete the square, I'm going to do a plus 4. Still have my minus 1. But again, boom, I just added out of thin air a 4 to that side of the equation. And I need to counteract it. I need to counterbalance it for the equality to maintain itself. Okay, I just magically put a 4 in there. So here's the catch. So you might think, oh, you just magically added a 4, so we just need to subtract a 4 to maintain the equality. But hold on, I didn't really just add a value of 4. Because this entire parenthesis is being multiplied by that 3, I technically added a 12. I really added a value of 12. So to maintain this equality, whoops, not there yet, I need to subtract 12. So, whoops, didn't mean to erase that. 3, the x squared plus 4x plus 4 would be x plus 2 squared. And then negative 1 minus 12 is negative 13. All right. So pretty challenging there. There's another method you can do these with. You could also, if you're interested, just do like the negative b over 2a, plug it in, calculate the vertex, get the vertex by doing the math, and then just write it in vertex form from there with this a value from the start. So I can to repeat if you want to do it a different way, and I'm sure you can find a way online that shows you how to do it that way, is you can just find the vertex by doing negative b over 2a to get the axis of symmetry, then plug it in to get the vertex, and then write it in vertex form from there with that a value. I wanted to do it the completing the square method because this is the more like mathematical advanced sort of way. So I want to do it that way. But yeah. Okay. So do your best on the rest.